So for the day 2, we're going to start with a warm-up here. And if you look, we're going to write a piecewise function for this graph. And if you look, we have the red line here. We have the part of a parabola here in green, and then the blue line here. Now, when we go to write this piecewise function, we always start with f of x equals, and then I start the little squiggly line, which that's really bad. Okay, so let's try this again. Not much better, but better. So the first thing we have to do is find the slope of the line. And if I find two nice points on this line, such as these, I could use any 2 points, right, such as these also. My rise over run is 2 over 1. So the slope of this line is 2 over 1, or 2. Now what I'm also going to use is the endpoint. I always use this endpoint, which is at -2, 4. So I'm going to write this in function notation, and I'm going to say, or point slope form. So 2 times x minus -2, which becomes x plus 2, all plus 4. Now the domain for this one, though, if you look, the arrow points down and to the left forever and ever. So we're going to say this is for all the x values that are less than or equal to -2. So now the green part is a parabola. And if I look, when we write the equation of a parabola, right, we always use the vertex, which this one is at 0, 0. So we know that this is going to be x squared. And if I look at my a value, over 1 up 1, this is for all the x values, right, that are between -2 and 1. So we're going to say greater than -2, but less than or equal to 1. And then the final part here, if I look, is up 1 over 1, 2, 3, 4. So the slope of this line is 1/4. Now, my slope is 1/4 times, I'm going to use this endpoint, which is at 1, 1. So it would be x minus 1 plus 1, and that's for all my x values that are greater than, right, 1. Okay, so you got to remember when the arrows are in the ends, right, when you're to the right, it's greater than. When you're to the left, it's less than. So, during a snowstorm, a meteorologist tracks the amount of accumulated snow for the first 5 hours. The snow falls at a constant rate of 1 inch per hour, and it continues. All right. So, when we look at it, what does f of 12 mean? If I look at f of 12, 10, 11, 12, that would be right here. And that would be the ordered pair 12, 9. Okay, and if you look up here, it says the first 5 hours, the snow falls at a constant rate of 1 inch per hour. So right here, if my x value represents time in hours, right, in snow in inches, right, what this means is f of 12 equals 9. So after 12 hours, there were 9 inches of snow. Okay, so you're basically interpreting all your x values will be hours, your y values will be inches of snow. So let's look at this now. Now, to graph these, it says Michelle and Rashid love going on long bike rides. Every Saturday, they have a particular route they bike together that takes 4 hours. Below is a piecewise function that estimates the distance traveled in miles. Okay, so right away we know our input represents hours. Our output represents distance. Now when I go to graph piecewise functions, I think the easiest thing to do is just plug the endpoints in, such as when x is 0, right, y is 16 times 0, which is 0. So I know I get an ordered pair of 0, 0 here. Then if I put the other endpoint in, when x is 1, my y value is 16 times 1, which gives me 16. And this ordered pair is 1, 16. So for this line, I know it's a line, so 0, 0, and then 1, 16. And now I can connect those endpoints. For the second one, right, if I plug 1 in, right, when x is 1, I'm going to do 10 times 1 minus 1 plus 16. So my y value here would be 10 times 0 plus 16 would be 16. So I'm going to plot the ordered pair 1, 16, which happens to be connected to the endpoint of that. Now my other endpoint, when x is 2, y is equal to 10 times 2 minus 1, right? And that's plus 16, which is going to give you 10 plus 16, which is 26. And this end ordered pair would be 2, 26. So 2, 26 would be right about here, and I would connect that. Now my next one, you know right away when you plug this endpoint in, right, 2 minus 2 is 0, 14 times 0 is 0, so you know it's going to be 226 again. Now when I plug 3 in, when x is 3, my y value would be 14 times 3 minus 2 plus 26, which is going to give you 14 plus 26, which is 40. So that would be the ordered pair 340. Okay, and then I would go ahead and connect those dots. Now the last one here, right, I know my endpoint again is going to start here because 3 minus 3 is 0, 12 times 0 plus 40. Now when x is 4, you're going to get 12, or y value of 12 times 4 minus 3 plus 40, which is equal to 12 times 1 plus 40, which is 52. So here you would get 452 and connect those dots. Alright, so this is the easiest way I feel it'll be for you guys to graph these. Now you could always plot these points and use the slope, but you got to pay attention to the domain. So it says what part of the right bike ride are they going the fastest and the slowest? Now, to be honest, I would use the equations to determine the fastest. Because what am I going to look for? The one with the largest slope. So here, my slope is 16, 10, 14, 12. Which one has the greatest slope? 16. So, the first part of the bike ride, right, and they are going 16 miles per hour. And when are they going the slowest? Well, what's the smallest rate of change here? That would be 10. So the slowest part would be the second part of the ride. And that's when they're going 10 miles per hour. What is the domain of the function? Well, the bike ride starts at 0 hours and goes all the way to 4 hours. So we would say the domain of this starts at 0 and goes to 4 hours. Okay, what is the value of f of 2? And explain, right? Well, f of 2, when x is 2, y is 26, right? Which means if f of 2 is equal to 26, that means after 2 hours, they rode 26 miles. How far did they travel after 3 hours? So when x is 3, y is 40. So they went 40 miles, right? Which means f of 3 is equal to 40. What is the total distance they traveled on this bike ride? Well, after 4 hours, they had gone 52 miles. All right, so let's take a look at the next one. It says, Rashid also rode his bike, has a route he likes to do on his own, and has the following continuous piecewise function to represent the average distance in mile after travels in minutes. All right, so this is now in minutes. So what is the domain for this function? As you can see, it starts at 0, ends at 100. So we're going to say from 0 to 100 would be the domain. So I'm using that and that to write my domain. What is the average rate of change over the interval 20 to 50? So if we look, 20 to 50 is here. So when I look at this function, it's linear. What is the rate of change there? Right? The slope of that is 1/5. Okay, which means, right, he travels 1 mile every 5 minutes. Okay? Over which time interval is the greatest rate of change? Well, what's the greatest slope here? Best thing to do is to convert these all to decimals. Right? 1/4 is 0.25. 1/5 is 0.2 miles per minute. 2/7 is 0.29. And 1/8 is 0.125. So what has the greatest slope, right? Over the interval from 50 to 92 is the greatest rate of change. All right. So you could use the inequality there if you'd like also to represent your answer, but they want it to be over what interval. So if we had to find f of 30, right, you have to know when x is 30, you are in this time interval. So you have to use that one. So f of 30 is, we're going to go 1/5 times 30 minus 20 plus 5, which is going to give me 1/5 times 10 plus 5. 1/5 of 10 is 2 plus 5 will give me 7. And it means after 30 minutes, he traveled, right, 7 miles. Okay? Now, what is f of 64, right? If I look at 64, that would land in this domain. You have to know which equation to use. So, we are going to do 2/7 times 64 minus 50 plus 11, which is going to give me 2/7 times 14 plus 11, which gives me 4 plus 11, which is 15. And that means after 64 minutes, he traveled 15 miles. Okay? And f of 10. Okay, when I look at f of 10, that's in the first one, right? So 1/4 times 10, right, is going to give you 10 over 4, which is 2.5. So when finding the output values for the given input values in a piecewise function, you must, right, look at what interval and function to use. Very, very, very important. All right. So if we had to find the value of a here, okay, what you have to understand is when you go to find the value of a here, a is always, if you look here, right, 20, 20, 50, 50. So this is just going to be 92 right away. So right away you notice a is just going to be 92. Now to find b, what I have to do is, if you notice here, if I plug 20 in here, right, 20 minus 20 is 0, 1/5 times 0 is 0, plus 5, right? 1/4 times 20 is 5. So where this function ends, this function begins, right? So this would be 25, which means this is also going to have 25 as your starting point. So now what I'm going to do here, right, if this is at 92, if I plug 92 into the function up above, 2/7 times 92 minus 50 plus 11, right, 92 minus 50 is 42, right, that's going to be 2 times 42 divided by 7 will give you 12. 12 plus 11 is 23. So when x is 92 up above, your y value is 23. So in this case, b is equal to 23. Now if we had to sketch a graph of this, right, I know right away it starts at 0, 0. And if it ends at 25, that's going to be my next one. 20 and then 5. There's the first leg of the ride. The second leg of the ride, right, it starts at 25 and then it's going to go 50, right? If I plug 50 in, 1/5 times 30 plus 5 is going to be 6 plus 5, which is 11. So right away this goes all the way to 50 and 11. All right. Now the next one, I know it's going to start at 50, 11, but then it's going to end at 92. We already said 23. So I'm going to go 92, 23, which would be here. And then the only thing I have to look at is after 100 minutes, right, 1/8 times 100 minus 92 plus 23. It's going to give me 1/8 times 8 plus 23, which ends up being 1 plus 23, which is 24. So it would be 100 and then 24. 100 and then 24. Boom. All right. So when you graph these, again, all you're doing is plugging the endpoints in and then sketch the line. Go ahead, try the homework, and I'll answer any questions tomorrow in class.